pouco então do controle físico e cultural.
Let's start. I will talk about physical and culture control. In the state of São Paulo, we have an excellent example of physical control, which is the production of baby plants in screened nurseries. This is an effective control. Unfortunately, we cannot screen all our crops, so we have to look for other measures regarding the crop and physical control. Yesterday, the Gene said something that is interesting. I think he said, Jim talked about the tree defender, that bag around the plants. I think we should discuss that. We had a similar study here in Brazil. We used a special type of mesh in Brazil, and during 3 years it was effective in the field. No plants had been inoculated with HLB. The problem is the cost of labor. You would have to change that 3 or 4 times a year, so that's not feasible economically. But those possibilities should be studied. Maybe they become more feasible in the future, especially in our areas that suffer great pressure. Today I'll talk about two things that in which we have been working. The famous primary dissemination. You have a commercial orchard or grove here. The psyllids leave this area and go to commercial areas. And I will talk about two studies we are developing here. At Fundecitrus, we are researching that. And the first one is the use of processed choline as a barrier. And it should be sprayed at borders of the groves, as Renato mentioned yesterday. And what would happen when we spray the processed choline? Yes, psyllids come, part of them would go to other areas, and few of them would be able to really go into the grove. We will also discuss in this presentation the use of the bait planting, which would be to use a plant that would be a great host for psyllids, and it would be immune to bacteria. And we'll talk about the study with Myrtle, and the idea would use the apply the systemic in the border. Insects would come, they will land here, they will be contaminated, they will die, and so you would reduce the number of insects that are affecting the whole grove. So starting by the processed choline. Why is processed? Because this material is already formulated, it has been refined, and it was developed to be sprayed in agriculture. The surround was developed in the US in a partnership with USDA. It is a non-toxic and non-abrasive aluminum silicate with a small particle distribution, less than 1 micrometer, and it's easily dispersible in water. So this is a choline that is formulated to be sprayed. Otherwise, we will, as Marcelo said, we end up having problems with spraying, but in this situation we would not find problems because this is a special choline, and it will form this white layer. This is a product developed as a sun blocker, but several studies show that it does interfere in the host selection of different vector insects. This is studied all over the world with Xylella fastidiosa, whiteflies, and now psyllids as well. So it might work as a repellent, a barrier to feeding and oviposition, and also cause a visual confusion as a camouflage. We have studied the psyllids in our conditions, and we have seen a little bit of each one of these effects for psyllids, and I will comment on those. Well, repellent effect. The first lab study would work with a treated plant with this product. We would put that in a cage, it would release several psyllids. The psyllids would have nowhere to go. Either the psyllids will feed on the plant or not, but they would have to stay there. We tried different concentrations, from 3 to 7. These are the choline treatments, the number of insects on the plants, and control. We had a reduction of 40% of insects that landed on treated plants. That shows the repellent effect. Using the technique that I mentioned in my first presentation, monitoring the insect behavior, we have seen that the ones that land on the plant eventually will get to the plant, And there is a reduction of 50% of those insects that are able to feed from the phloem. So they reduce the probability of inoculation because the bacteria are here. Bacteria are here in the phloem. Of course, the other half end up getting to the phloem, but it does have a repellent effect, and it does affect the insect behavior that would help then in management. That was under lab conditions. But what happens on the field? We have carried out studies. This is an experimental grove from Fundecitrus in an area that was given or allowed us to use by Mundiara. So in here we have different plots with the plots treated with processed choline and with the control. And we wanted in this grove to simulate an abandoned grove. At each end out of the grove, we used the technique of Professor João Lopes, marking insects. In each experiment, we released 4,400 psyllids for the different treatments, exactly to simulate an abandoned grove. And our vision for this product, just as everything that we do here, is as a preventive measure. If we have a high population here and we apply choline, it will help you, but not enough. And here we did not have the psyllids. We sprayed and released the insects because we wanted to understand the preventive primary dissemination. In the first experiment, plants did not have sprouting. We had a first spraying, then a second spraying, and then we released the insects. All the plants have been inspected so that we counted the number of insects on each one of the plants. So in the first experiment, there were significant reductions when we compared those to non-treated plants to the processed choline-treated plants. And then we thought, let's hold a second experiment, but under a more different condition. So we had a light pruning. It started sprouting in that condition that you said it was ideal for psyllids. For V1, from V1 to V2, we started spraying. We had the first and second sprayings, and we here assessed up to the 7th day. Once again, we did have an interesting result, a reduction of the number of insects per plant, here comparing control, non-treated, and treated plants. And we have a very low number of psyllids here. And what we can see is that 7 days after the insect's release, the sprouts, as you can see, with no coverage of choline were here, but the mature leaves did have the choline. And we thought, what if after 7 days a new group of insects would combine? Based on that, we carried out a third experiment. And in this case, we did exactly the same thing as the second one with sproutings, plants at V2, V3. We had the first release, 4,400 insects, and then a second release of 4,400 insects in another week to see what would happen. And it's interesting here because we had a lot of rain in this experiment. That's good for us to understand how this product behaves under rainfall. As expected, we had lower reductions, but then they were still significant, 85% reduction when compared to non-treated plants, showing that this product has a great potential to be used in the border of groves and areas that are under pressure of this insect. But we need to understand and study this further. Well, another piece of data, you see that mature leaves were still kind of grayish, and you see here the sproutings at the final stage of maturation without the coverage of the product. Based on that, we thought, should we increase frequency in that situation of sprouting? And that's the same that we are proposing insecticides, which is an ongoing study right now. And interestingly, you look at the infestation maps of the 3 experiments. The dark areas are the ones where you have a greater population of the insects, so where you have C is control, and here you have processed choline. So you see a clear concentration of insects here in the 3 experiments in the control areas. We held a second experiment. This is a grove with a low management of HLB. This is a grove of acid lime. This is an ongoing experiment. And we said, okay, 3%, interesting result, but what if we had 2%? So this is an average number, same thing. In this case, we have a natural infestation condition. We did not release ourselves the insects. And we do see that even then, we had the non-treated plant and we had the processed choline at 2 and 3%. But we will extend the experiment up to the end of October so that we can get that stage of the higher population of the psyllids. And the choline will be working then. And at the same time, we are developing other experiments in our experimental grove, releasing insects in areas that are weekly or biweekly treated during the sprouting period. This is a reduction of 97%. And something else that is interesting that we are analyzing it. Yesterday, Jim talked about the reflective mulch, and we are trying to study that in Brazil, but in our conditions, the mulching loses that reflectance ability. But for us, everything that reflects is influencing the localization of the hosting plant by the psyllid. And here, in a partnership with the Physics Institute, we see that a plant with no processed choline treatment will have some reflectance. This is a plant with low coverage. It will be reflected a little bit more. And a leaf with greater cover will have more reflectance. So that helps you to understand that repellence on the insect. And the final objective is to understand if this product, when it is applied in commercial farms in larger areas, if that is going to reflect in lower incidence on HLB. So this is a study that has started this year. We are spraying it in initial groves and adult groves. This is a picture taken by a drone. You can see the area treated versus the non-treated areas. You have large plots of 1 hectare. We will be able to measure that in the next few years. So this is a product that, considering our results that we have, has an interesting potential to be introduced into the HLB management here in the state of São Paulo. Now turning the focus, going to the bait planting with the Miranda. Some studies have been held in the past, and probably many of you have seen it. And this is Washington Luiz at Cambuí farm, and we developed this experiment there to analyze the bait planting. As I said in the beginning, the insect will come, will land on this plant, it will feed from the plant. These plants are treated with systemic insecticides, and the plot was sprayed. These plants were sprayed as well. So we worked on that on 6 months, and after 4 years, the grove grew a lot, and also Mirandas also have grown a lot. They received systemic insecticides, and when we would spray the plot, we would also spray the Miranda. So this is a single plot that we have studied, and we already see a reduction. Look, this is the control, the range of plants with no bait planting, comparing to the area of planting that did have the bait planting, and we did find a reduction in the number of psyllids. Also important is the capture frequency, regardless the number, and here we have the amount, but the frequency, the number of times that we found psyllids with and without the bait planting. And with the Miranda as a bait and in biweekly evaluations, we had 26 times against 74, almost half, showing that bait planting also reduces the frequency and the amount of insects that reach the grove. We also carried out a study, and this is a preliminary one. It took 4 years, but it was a single plot, and in the area where we have the bait planting, we found a reduction of around 40% of plants with HLB compared to the area with no bait planting. So this is an interesting technique and very promising one. Well, in this last year then, we started a new study that Arthur Tomazetto is at the head of it, and we wanted to corroborate these data in a single plot. So we used the same technique, and here the same grove, instead of choline, we removed choline and we planted the Moria on the same size of the grove. This is a 2-year grove at the same height. This is important. And we then released insects once again. These were Morias treated with systemic insecticides via drench. We released then the insects. We held three repetitions actually, and we released a larger amount of psyllids than before. Here in the first time it was 4,800 psyllids, and in the second and third repetitions 6,000 psyllids, and we simulated that abandoned grove. And here you see the grove with the bait planting and without the bait planting, the control. These are meteorological conditions in the different repetitions and temperatures and rainfall, and you see a significant reduction. You see the control in these areas without the bait planting when compared to areas that did have the bait planting. We also found significant reductions of the number of insects that might and that can actually reach the grove. Now with the infestation maps summarizing the 3 experiments, 1, 3, and 7 days after release. Once again, you see the behavior of the areas with no bait planting when compared to areas that have the bait planting. You have lower insect infestation. Something else that is very interesting, as I said, here we have marked insects with different dyings, and you could see from where insects were coming. So insects that were released here in front of the bait planting, we found some of those to the area of planting. Why? They came in, there was no barrier, and the bait planting, we also have a lateral movement, and if we did have a whole wall here with the bait planting, probably we would not have had that. So this is very interesting, it is promising, and we believe that in the future we might be able to integrate that in the psyllids management. With this experiment also, we held previous studies with systemic insecticides that they do work with Moria, but with this experiment that I just mentioned, there was a whole set of plants that were left aside because we just wanted to confirm that the plants were killing psyllids, so we would confine the insects during the experiments, and we can show here that we have a mortality of 100% when compared to control plants that had no spraying. Here you see the psyllid here in green, and this is a psyllid from a specific soccer team in Brazil that never gets to win, never gets there, so he's always dying. And so there is another one, the red, from another soccer team. It ends up dying in the plant that is treated with a systemic psyllid. And another interesting piece of data, if we look at it, what we call the finding rate of the insects, when we compare the release studies, these studies, you release a lot of insects, but the finding rate is of around 5%, and that's what we have in the study with the choline. Now, with this work with the Moria, we had it at 10 times less. Why? And I did not bring the data here, but we would also inspect the Moria, and we found a lot of insects there, and they were dying, and that's why we reduced that finding rate, because they really, the Moria brings these insects and they end up dying. And to conclude, I believe that our strategy what we believe, the push, pull, and kill, in order to kill the insect, I think this would be ideal to reduce dissemination. We have the non-managed grove with a high population of psyllids, the bait planting, and the plants treated with processed culling. So what would happen in theory? As we have seen, some of these insects will come, they will stop in the Murta, in the Moraia, as we have shown, and some will go through it. Nothing is 100%, they will go over, and obviously some will end up breaking all the barrier and establishing themselves in the groves, because nothing is 100% perfect. And the idea of this project of Fundecitrus, regardless if it is Moraia or Bergera, and Pedro's studies have shown that Bergera is also attractive to psyllids, but our idea is to develop a plant with a lethal gene to the psyllids, and Nelson will talk about that in his presentation, regardless if it's going to be a Moraia or Bergera. And what is important is that Fundecitrus does not recommend, I want to make it clear, we do not recommend Moraia or Bergera planting by citrus groves and having systemic applications. Although you have interesting results, imagine that the grower decides to plant something else for sugarcane. All this area of Moraia, you will not be spraying systemic insecticide there, so you might end up having a really a huge population of psyllids there. So if you don't apply systemic insecticides, you will have a problem. So we want to have something that is more sustainable. We don't want an environment where you have to apply systemic insecticides all the time, and we don't want you to spend money with the systemic insecticides. So once again, thank you very much to my team, the partner companies, and also citrus growers. Thank you very much.